Hey, hope you're all having a good day. My name is Hector, and I'm going to go through question 46. Two wires are tied to the 300-gram sphere shown in the figure. The sphere revolves in a horizontal circle at a constant speed of 7.5 meters a second. What is the tension in each of the wires? So I went ahead and drew a little picture of our scenario. It looks something like this. We can divide each one of these into their respective triangle, solving for our angle, which I ended up calling phi, which is this angle right here, which should also be, should also be half of theta. We can do this also using the inverse sign. There are a few ways to solve this out, but just kind of showing different ways. We can divide them into two triangles, and we can imagine this and sum up these forces. So if you wanted to draw a force diagram, it would look something along the lines of this. We have our little singular point, our gravity pulling it down, so that's going to be Fg, on our tensions. So I'm going to draw it flipped here instead of the other way around. I like drawing it to the right. Tension here, tension here. These are the same tensions. They should be the same directions, but I have it mirrored. And we can imagine, if we wanted to get a little bit more in detail here, the components of these. So this would be my net force, and I'm going to call this actually T3. A component this way, that would be my sine component. So T1, I almost wrote cosine, sine of my angle phi, and I can imagine also some component here pulling this down, and that would be the corresponding sine phi of that. So you can imagine this, and we can kind of sum up all these forces. So in the x direction, we have that centripetal force. It's making it go around in a circle, this mv squared over r term, right over here. And that should just be equal to our two forces in the x direction summed together. In the y direction, it's very similar. We just have this tension 1, the y component, fighting both the y component of tension 2 and gravity, and that should be equal to 0. We can then solve each of these for T1, which I've done here down below. So this is the equations respectively solved for each one of their variables. And then, since they're both equal to T1, we can set them equal to each other, solve out for what T2 is, so it's this number right here, and then we can solve out for what T1 is. So numerically, this is our answer, 8.31 newtons for tension 2, and for tension 1, it's 14.19 newtons. So, really isn't that bad of a question. Just remembering to set up your second Newton's second law, making sure to notice that, and I forgot to mention this a little earlier, which maybe we probably should have, is this r value, right? This r value is actually going to be the x component with respect to phi of our respective triangle. So if we imagine our triangle, it'll have this 1 meter here, some x component, some y component. We want this x component, and that'll just be the magnitude of, we're imagining this as a vector, times their respective trigonometric function. And yeah, that really just about does it. I hope this was helpful. Again, Newton's second law, and just making sure that all the variables are in line. For me personally, just getting everything sorted, the plus or minus signs, making sure everything's going the right direction, making sure you're sure where you define. So for instance, I defined positive as going towards the center, but you could define it as negative, in which case both of these would be negative. And yeah, really just about does it. I hope this was helpful in some way. You have a good day.